Okay, so today what we're going to do is we're going to look at simplifying some algebraic expressions, and specifically with a focus on multiplication problems, right? Which is why we're also looking at indices here, because an index or a power or anybody else know the other word? Exponent, right? So we have index, power, exponent. All of those things mean exactly the same thing. It means to multiply something times itself over and over. So the first thing I want to do is I want to talk about that, okay? So when you're talking about an index, what you have is some base raised to some power. And I'm just going to use general form, which means letters instead of numbers, so that you can, because it applies, shows you a rule that applies no matter what your numbers are, right? That's why mathematicians use just letters, because that should tell you this rule applies no matter what numbers you have. Okay? Yes?
So that's an index.
So A, let's define the pieces. A in this case is what's called the base. Now I know we've had a base before. A base is the variable, but remember, we're talking about an index now, not a term. So the same word can be used over and over and over, and it pretty much means the same thing, but it's used in a different context. And our n here is the index. And again, that's not the only word for it. What other words could you use? Exponent or power, exactly, good. And they're all interchangeable. It makes no difference to me which one you use, and you'll hear me use them interchangeably as well, because I'm trying to get to use index. It's really a very formal way of saying it that is absolutely correct. It's just not one that I typically use. Most of the time I'll say index or power, but or exponent and power, but index is the same thing. Okay? Now, it's very important to understand the base of an exponent and what the exponent is. So say, for example, we have 4 to the third power. Okay? And what that means is that you're simply going to do repeated multiplication. So does that mean 4 times 3?
4 times 4 times 6.
Exactly. It means 4 times itself how many times?
3 times.
3 times. Right? Anybody know what that is? 4 times 4 is 16, times another 4 is...
64.
Okay? All right. So, now, where it gets a little trickier is when you have signs involved. And I was looking through your past assignments, some of them, and you did do an assignment in Education Perfect about sign numbers, but we're going to continue to talk about that and refresh your memory of it. But let's say I have -2 to the 4th power. So there's a minus in front. So that minus is the sign of the term, not the base of the exponent. Okay? So be very careful. So one way you can think of this is the base is only the thing the index touches. Okay? The base is only the thing that the index touches. So is that, the index is the 4, right? Is that 4 touching that minus? No. Then it is not part of the base. Therefore, it does not get multiplied together over and over again. Instead, it just follows along and just stays a minus. Now, what is the 4 there? Well, it doesn't really touch it, but it looks like it's right on it, right? What is the 4 touching in this case? The 2. So the base is the 2. So it's not the negative we're multiplying over and over and over again. It's just the 2. Okay? So the base, again, is only the thing that the exponent is touching. And it's not really touching it, but it's right there on it, right? So it's a little bit of a stretch, but not too bad. Now, if I were to do that then, what I would do is simply drop down the minus. It's not going to change. And now let's do the multiplication inside. 2 times 2 is 4. 2 times 2 is 4. And 4 times 4 is 16. So I end up with a negative 16 as my answer. Make sense? The most common mistake right there.
Does that make it a positive number?
No, because the minus is in front. So it's a negative. It stays negative. Now, however, now be very careful here. And I am going to make sure that I am a total pain about this because you need to not get into bad habits, right? That's my job right now, is to make sure that you don't get into bad habits that you then take with you to calculus. Because if you do, you're going to always have trouble, right? So I'm going to be really sticky about making sure that you say things properly. Because if you're careless, then it's going to hurt you later, right? Remember, I already have a degree, so I don't have to really worry. But you're the ones who have to pass, right? So make sure you're saying things correctly. Yes. It's just a higher form of mathematics. Mm-hmm. Okay. Now, it's really the mathematics of motion. So some of you will take it, some of you might not. What is the exponent here, or the power? The 4. And what is the 4 actually touching? The parentheses or bracket, right? It's not touching any of those numbers, is it? So the base of this exponent isn't the numbers, it's the what?
Bracket.
The bracket. So the numbers are just going to follow along. Now, of course, the numbers are the part you're going to multiply, but the numbers are just going to follow along. So what we have here is negative 2 in parentheses times negative 2 in parentheses. How come I'm not writing a multiplication symbol?
Because you don't have to.
I don't have to, right? If I have a bracket next to a bracket, then that automatically means what operation? Multiplication. Okay? All right? So it means to take that parentheses times itself 4 times. Okay? Now, I purposely used a negative number here because I want to remind you about some things about signs. If you don't remember them, don't worry. We will do a lesson about sign numbers, but I just want to do it to make sure to see kind of where you are. Now, so I'm multiplying. When you're multiplying, we don't multiply 4 numbers together all at one time, right? We'll take 2 of them, then take another one, then take another one. So take it in small pieces. So let's take this negative 2 times this negative 2. Does anybody remember what a negative times a negative becomes?
Positive.
A positive, right? And again, if you don't remember that, don't worry, we'll talk about it. Right. But I still have to multiply that answer times these, right? Now, I'm writing down a lot more than you normally would. So those 2 multiplied together became a positive 2, right? Well, I could have done this as well. Let's do that one as well. Okay. What is this negative 2 times this negative 2 going to become?
2.
Another positive 2.
Yeah.
And I'm still doing what to those 2 things?
Times.
Multiplying them together. So in reality, the parentheses or the multiplication is not gone. And positive times a positive is still going to be a positive. And 2 times 2 is...
4.
Oh, can I multiply 2 times 2 and get 4 a minute ago? Good Lord. That's a 4, not a 2. 4 times 4 is 16. Thank you. Sorry. I was so caught up on the sign that I can't multiply.
Can you keep this up this way?
Of course.
Can you explain that last part again, please?
Sorry?
Can you explain that last part again?
Okay. So I did the multiplication here. It just gave me positive 4, even though I wrote down a 2. Y'all got to watch me.
I'm just writing.
And then 2 and 2 gave me a positive 4 here. And then finally, since I multiplied those 2 together, I still have to multiply the answers together because I have to end up multiplying everything together when it's an index, right? So when I bring it down here, it's still multiplication. So 4 times 4 gives me 16. Okay? Yes?
Is the education thing that is for this lesson, is it simplify multiplication using indices?
Right, and so we're talking about indices first, so they give you a little practice. So that's what we're doing, is the indexes, right? Okay, now, so let's go to our lesson, and we're going to walk through some of these. And again, you're going to see some of what I've done, but this is huge. And so I'm always going to, if there's any part of the lesson that I really, 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 really know that you're going to make mistakes, simply because for 20 years I've been teaching this and I know what students do, right? Now, y'all aren't, right? Because you know that every other student I've ever had has had problems here. So that if you know what happens, if you know where the problems are, then you don't have to worry about making the same mistakes that they make, right? So let's go to... Exactly. Okay, so today what we're going to do is we're going to be looking at, again, hold on guys, we're going to be talking about simplifying multiplication and division. Because remember when I first introduced the idea of algebra, I told you that the operations can sometimes look different. For example, we talked about multiplication and said that multiplication, we don't really like to use the x anymore, we use a dot. Or if I wanted to say 4 times b, I could just write 4b. If they're side by side, you know that means multiplication. So we're going to do a lesson about multiplication and division, and talk about some indices that have so that we can learn how to simplify these as much as possible. Remember, the understanding of the way things are written is very important. If we wrote everything out that you already knew, but we wrote it in Greek, how successful would you be in history class, right? It's the same words, but they're written in a different language. So if you don't understand the language, you're not going to understand how to deal with the problem. And that is most of it. I'm telling you, 98% of your problem in mathematics is not understanding what you're being asked to do. Okay? So if we focus on that, then we can have a good out. Now, I don't know what the sloth is about, but there he is. It's pretty good, though. That's one of my favorite animals. I don't know why. Yeah. Exactly. So you might have noticed that in algebra we want to write things as simply as possible, right? So instead of 4 times b, I would write what? 4b. Okay. Instead of using division, we're going to use another symbol for that. So you're going to see that things are simplified as much as they can. Okay? So in mathematics, there's special rules to save time and be able to simplify the expressions. And we've looked at this one before. Instead of saying 3 times a times b, how could I write that?
3ab.
As just 3ab. Right. Multiplication is the only operation that requires you to have no symbol at all. Okay? Now, but remember, we also showed an example of this. Can I do the same thing with numbers? Is 2 times 4 the same thing as 4?
No.
No, you cannot do it with numbers. And what are the numbers called? Do we remember that that word for numbers?
They call it
Constants. Remember that they're called constants. So you cannot do it with constants. Might as well use the language, right? You can't do it with constants, but you can do it with variables, right? Excellent. Good job. Okay. We can also simplify division. You will still, in algebra, see the division symbol used. That little division symbol is not going to go away. But if you look at the division symbol, it actually looks like something else that you're very familiar with. Doesn't a division symbol look like a fraction?
It's an empty fraction.
Exactly. So that division symbol literally means divide by. So if you see W over 5, that literally means W divided by 5. Okay? So a fraction, every fraction that you see is really just a division problem, right? But because we can't do the division, then we end up with a fraction. Now, in a case where you can do the division, so what's 8 divided by 4? 2. Then the fraction goes away because you've performed the division. And once you've performed an operation, do you still need the operation symbol? No, right? 3 times 2 is 6. not times 6, right? It's just plain old 6. What happened to the operation symbol?
It disappeared.
Well, we used it, right? Let's say you go into a store and you have $20 and you spend $20. Are they going to give you your $20 back? No, right? So you've used it. It's gone. All right. Excellent. So we can write division as a what?
Fraction.
As a fraction. And that is the most common way in algebra for writing division. And I want you to get used to it and start writing all division as a fraction from this point forward. Okay? Now again, you will still see this symbol used, but for us it's better to write it as a fraction. It's more simple. Okay? All right. Also, remember that when you're talking about working with fractions, there are some things that you can do to simplify your work. Think about back when we had the area formula for a triangle. It was area equals 1/2 base times height, right? And we talked about the fact that multiplying by 1/2 is the same as dividing by what? 2. Okay? And that's true of any fraction where the numerator, the top number, is a 1. You can just think of that, instead of thinking of it as multiply by the fraction, it's the same as divide by the bottom number, which is called the what? You may remember? Denominator. There you go. So 1/5 times W is the same as W divided by 5, which is the same as W over 5. Do you agree? And it's easy to think about that if you think about the rule for multiplying fractions. If you have a plain old W, where is it in a fraction? In the bottom or the top? Yeah, if it's just a plain W, that really means the same as W over 1, right? And then when you're multiplying fractions, how do you multiply them? Just straight across. So 1 times W is W. 5 times 1 is, so W over 5. So,
Wow.
all right? So we know exactly the same thing. Yes?
That only works if it's a 1.
It only works, you can only just change it into division if there's a 1 on top. If there's another number on top, then you really have to just multiply it out. Because now it's not just W on top, it's 2 times W, which is what? 2W, and 5 times 1. So you still ended up dividing it by 5, but because the number on the top was not a 1, it adds some more, and adds another layer, adds more into it. Okay? So you can't just automatically think, oh, I'm just going to change that to divide by 5, right? Because of the 2, you also have some multiplication to do first. Good question. Now look at this one. This one is a little strange, but it's really saying the same thing as this one. Because if I have 1/5 in front of W, what does that literally mean? 1/5 times W, right? So that's 1/5 times W over 1, which is W over 5. So do you see where they get the answer?
I don't know if this is right. Instead of just doing like 1 over 5, I do like 1/5.
Okay. Yes, that's a great question, and it's completely wrong. So love that? Okay. In algebra, if you use that symbol, which all of us have used for a fraction forever and ever and ever and ever, guys, come on. This is really, in algebra, that's the symbol for or.
Oh, really?
So if you write 1/2 that, you're really writing 1 or 2. Now, we've all done it, and you will see me do it, because in arithmetic, it doesn't matter because we don't have that symbol for or, right? So in arithmetic, a lot of times we use that slash to make things work. But if you have in algebra, you can have more than one term in a sentence, right? So I can have an x plus 5. Well, if I write 1 over x plus 5, what's the only part that's the fraction? Right? It makes it look like that's the only part of the fraction. But what if I write it like this? Now is it clear that the x plus 5, the whole x plus 5 is in the bottom of the fraction?
Yeah.
Okay? So do not use the slash anymore. Okay? From this point forward. Yes?
But isn't it like when you're writing and you say like you have to do this and then there's like for example, if you don't know someone's pronouns, you go she, he, and then there'd be a slash.
Like a slash,
or,
he or she, yeah. And that means he or she.
Or.
Exactly.
Okay.
So it's a convention that you use in English as well. Okay? All right. Let's move on. So here, what I want you to do is I want you to simplify this expression. Ready? Everybody's got paper and pencil, even if you're taking notes, or you can type it on your computer. But go. You got my favorite animal. Be careful. Remember, we're talking about multiplication and division here. We can write those differently. Okay, do we have an answer, somebody?
Yes.
Who wants to volunteer? Okay, go ahead.
4x plus 3. Oh, and these brackets are open.
Okay.
Actually, no.
Well, you can keep them or not. Actually, you're entirely right. You can keep them or not.
Keep it.
You want them? Okay, that's fine.
Divided by 2.
So divided by like that?
Yeah. Oh, no. The...
Yeah, there you go. Divided by, using a big fraction bar, divided by what?
2y.
2y. Everybody agree?
Oh, and there's no... I don't want brackets.
And you don't want the brackets? Okay. Now, she's bringing up a really good point here. It is not wrong if you leave the brackets. But in algebra, remember, we're lazy. Algebra is a lazy math. We don't want to write anything we don't have to. So, I don't need the brackets. However, if you don't write them, you still have to remember that they're there. Okay? So even if you don't see the brackets, in reality, there is a bracket around this, and there's a bracket around that in every fraction you do. So if I have just the fraction 2/5, there is a bracket around both of them. Okay? And that's important, because when do you do brackets in the order of operations?
Second.
First, right? So that tells me that if I have something to do in the top of a fraction, or I have something to do in the bottom of the fraction, that I have to do that first before I do the division. Right? So, okay? All right, guys, are you ready? Do I have to write the brackets around the numbers on the top of the fraction?
It takes extra effort, and you don't want to have to waste your effort.
There you go. But are the brackets always there?
Yeah. No. Yes.
Yes. You just don't have to write them. You can assume they're there, right?
Well, I mean, it only
Okay.
makes sense because it's not like there's many operations. It's just black.
Okay.
So, you know.
But, so say like you had, for example, oops, the eraser's not going to do it. So if I had 2 times 3 divided by 3, you might be tempted to just say I can eliminate those. Well, let's do 2 plus 3. You might be tempted to say I can eliminate those 3's, but I cannot. It's wrong, right? What I have to do is, because there's a bracket around those, an imaginary bracket, it's assumed to be there, I have to add the top 2 before I could do anything else. And now can I divide anything? Nope. Okay? So they're in brackets, and you cannot, so you have to do it first. So even if you don't see the brackets, they're there. Excellent.
If there weren't brackets, what would the answer be?
There are.
But if there weren't, if what was that 2 plus 3?
It can't be, because it's in a fraction. They're there. You see what I'm saying?
Always brackets.
Yep. Even if you can't see them. So even though I can't see the brackets around these, they're there. And you must assume they're there, always. Okay? Excellent.
Well, don't we work left and right? No.
Brackets first always.
Yeah, but that's different brackets.
Yeah, well, but it doesn't matter because there is a bracket. Even if it's not, you can't see it. Okay? Another big problem is. Right? So, anytime you have variables between coefficients, you just remove them. So they're just, what they've done is just do this problem. So you see 4x plus 3 over 2y was our answer, right? It's a lot easier to read when all of those symbols are gone. All the unnecessary symbols are gone. And now look at the bottom. It says, and it does not require brackets, right? To show that these things need to be done first. Because we know that there's a bracket around the top and a bracket around the bottom. It's just there. We assume it to be there. Okay? All right. Select all correct options. Right? We'll just do this as a class. Our question is, when can we remove a multiplication symbol? When it's between a variable and a coefficient? Yes or no?
Yes.
Yeah.
Wait, what's a coefficient?
What's a coefficient?
A number.
The number part, the constant part of a term. Good.
Is it
So yes, right?
Wait, is a constant the same as the...
Constant number means exactly the same thing, right? Because a number can't change, so its value stays constant.
So then what's a coefficient?
Coefficient is the number in front of the variable. So 4 times a is the same as 4a. That 4 is the constant, the coefficient, right?
How do you spell it? Constant?
Constant, just constant. Whoa, my handwriting is getting really worse. All right. How about when between two coefficients?
No.
No, because a coefficient is the number part, right? And so it can't do just 2 times 4 can't become 24, right? How about when it's between two variables?
Yeah.
Yes. I don't have to write a times b. I can write what?
AB.
AB. Excellent. How about when it's between two constants?
No.
No, because a constant and a coefficient mean the same darn thing, right? Okay. Excellent. Good job, guys. Oh, it's not clicking because I've got it in writing mode. Okay. Simplify the expression. Go. 30 seconds.
30 seconds. That is not very much.
Yeah.
Maybe that's bad. Sorry, I'm not.
You can check with your neighbor once you've got an answer, once you think.
This isn't writing. Oh, you're just writing now. That's great.
I got 9K plus 7. 9. Yeah. Yeah.
Okay, there we go. Who wants to say? Go ahead. Sorry, she was faster. Yep.
9K plus 7P.
9k plus 7p. Do we agree?
Yeah.
Sure. We can simplify 9 times k as just 9k. We cannot simplify plus, right? But the 7 times p can just become 7p. So 9k plus 7p. All right. Excellent. Now, this is all we've bled over into your homework. I didn't mean to do that. So let's look at our next lesson. Yeah, that's stuff y'all are going to do.
Bled into our homework.
Remember that the purple ones, right? These guys
A constant.
are for y'all. Those are the ones y'all are going to be working on. And I started doing one of them, so I'm going to stop doing it now. All right. So let's look at some other things. So when we multiply or divide variables, we can multiply and divide their coefficients as well. In other words, if you think about when you're doing the mathematics with variables, the only part that we're allowed to change is how many of them we have, which is the coefficient, right? And we kind of looked at that a little. And so what you can do is I can multiply numbers together, but I can't multiply a t times a w because I don't know what they are. But I can simplify it. What would I write if I had t times w? TW. I can still do that. But the number parts are still numbers, remember? So numbers we can multiply all day long. Okay? So what you want to do here's some little notes, to multiply terms. First, do the sign. Sign errors are the biggest mistake that algebra students make, so always make sure that you do the sign first because that gets it out of the way and you know you've done it correctly, right? Think about it. If you know that something is hard for you, then you need to really concentrate on making that work, right? So if you know that the biggest mistake are signs, then we know we need to concentrate on signs. Then, and we'll talk about sign rules as we go, so don't panic there. All right, then what we'll do is multiply the coefficients. And the coefficient simply means the number part, right? And then we're going to keep any variables for now. Later, that's going to change because you're going to see what happens when we multiply some variables together. But right now, we're just going to keep them. So, looking at their example, 3t's times 4w's. Well, I can multiply a 3 and a 4, can't I? What's 3 times 4 going to make? 12.
Wait, what's the sign?
Well, but is there a sign, a plus or minus in front of these? No. Well, so if there's not, we assume it to be a plus. So in other words, we don't really care. But yeah, when it has minuses, those negatives in front, that's when it gets boring. So I'm sorry, I should have done that. A positive times a positive is going to stay a positive. 3 times 4 is 12. And what's t times w make? TW. You can't multiply a t times a w, so you just get TW. Okay? Pretty easy because all you're doing is multiplying the numbers, which is what you've always done, right? Okay. So, I don't know why they gave us 2 pages of that, but there you go. So you multiplied the coefficient and kept the variable terms, and you end up with 12TW. Can I write it as 12WT?
No.
No. Remember the convention is that any letters have to come in what kind of order? Alphabetical. Excellent. Okay. Simplify this one. Go. 30 seconds. Now be careful. There is a sign here this time, isn't there?
Ooh.
Give it a shot and see if you...
I think I just broke something in my bones.
In your bones or in your brain?
Both at the same time.
Okay. Do your work. Sorry. I'm getting you off track.
My brain is really
What's the sloth's name?
Shh, that's not relevant.
It's completely
Shh,
relevant.
not relevant.
It's completely relevant.
Okay.
That is not enough time.
Yeah.
Was it? All right. Go ahead. 30 more seconds. Come on.
Can you please tell me the sloth's name?
It's Mr. Self. Look at him.
Okay.
He looks just like me.
You don't have glasses or a tie?
Or a book.
Yeah.
And you're also not a sloth. But that's very nice.
That's debatable. Okay. Does anybody have an answer they want to share that they want to try?
No, I don't.
Y'all aren't very brave. Yes.
Minus 3PQR?
Minus 3 PQR?
Yeah. Or just 3P?
Let's think about it. First thing we need to do is do the sign, right? So let's just walk through it. Yes.
Okay, well, can I just say something? Minus
Quickly.
5 plus 2 plus 3 is nothing, right?
Well, but these aren't plus.
Oh, okay. Yeah.
Multiply.
30PQR?
Yes,
Wait,
30
what?
PQR, isn't it?
30PQR?
Close.
Minus.
Minus 30 P. Yeah, there you go. So look here. We have a sign here, right? There is no sign there, so we assume these to be positive. What's a negative times a positive make? A negative. And a negative times another positive just stays what? Negative. Be careful. Negative times a positive makes a negative. Times another positive stays negative. Right? Now, what are my numbers? 5, 2, and 3. So what's 5 times 2?
10.
10. And 10 times 3 is 30. Now, what is a P times a Q times an R?
PQR.
PQR.
Whoa.
Because we can't multiply those, all we do is stack them together. Good job. So minus 30 PQR. I think the problem there was not that you didn't know what you were doing, you were just not brave enough. Come on, guys, be brave.
No, I did do it. It's just I forgot. I forgot I said 3 instead of 30 the first time. And I wasn't sure if it was minus or not.
There you go.
Isn't that the answer?
Yep. Negative 30 PQR.
Simplify the expression.
That's algebra. You simplify it, not answer.
Right, because we didn't really answer it because I didn't get 7, did I? Because I don't know what PQR is. What I did was I simplified it by eliminating all of the things that were unnecessary. I did all the multiplication I could, and I got rid of all the unnecessary symbols, so that's simplifying it. Okay?
Simplifying is taking out the... Simplifying means do whatever you can. It's the math term for do whatever you can. Okay? So there's what we did. Okay, excellent. Then let's look to make sure our answer is correct. Negative 30 PQR. Okay? All right. So then it goes back to work for y'all. Let's see what our next lesson is. Index notation. Now this is really important. So focus with me here. I know it's toward the end, and I'm making y'all work more than you normally do, but you're considered. Okay. Repeated addition, right? If you have repeated addition, that's what multiplication is. 3 added together 4 times is the same as saying 3 times 4. That's where multiplication comes from. You're doing a repeated addition with the same number over and over. Well, if you're doing repeated multiplication, there's a simplified way of writing that, right? Simplify because we can write that using an index or an exponent. If you have 3 3's multiplied together, we can change that. Instead of writing 3 3's multiplied together, we can simply write 3 to the 4th power, okay? Or an exponent of 4. So all the exponents or the index mean is that you have more than the same thing multiplied together. Well, if that's true for numbers, then it also must be true for things that start with a V. Variables. There you go. So if it's true for numbers, then it has to be true for variables as well. Okay? So, if you just have an x and a y multiplied together, then we get what? XY. But what if I have a bunch of x's multiplied together? Right? Oops, sorry. So here I have what? I have 1, 2, 3, 4, 5 x's multiplied together. I could stack them up, and you see that's what they did here, right? But that still just means a bunch of x's multiplied together, right? Or I could think of it as
5x.
not 5x, but x to the 5th to the power of 5, right? Remember, it's repeated multiplication. That's an exponent or an index. So it's x to the 5th power. So what if I had 12 of them multiplied together? X to the what? 12. Okay? So just count up however many you have multiplied together, and that becomes your index. And here they're just going through that lesson about the bases. Don't worry about that too much. We did that. Then they did the sloth. Right? Okay? Now, here's something that's very important, though. If something doesn't have an index or an exponent, it does.
Wait, but...
All right, here we go. We just assume it to be there. So if I have plain old g, that's the same as g to the 1st power. Or g to the 1.
G times 1 is G.
Well, not really. It just means g times g once.
Yeah.
And g once is g, right?
G once is also G times.
Okay.
Right?
No.
Oh.
It just means g once, or 1g, right?
Okay.
See, this means g once. This means g twice. That means g what? 3 times. I almost said thrice for some stupid reason. All right, there you go. So if you don't see an exponent, what do you assume it to be?
1.
A 1. Okay, good. Come on, guys, I don't want to lose you now. If you have 2 g's, we often talk about that as g to the second, or g what? Squared. Square always indicates an exponent of what? 2. Okay? And so they're talking about the base and the index. So here, the base, if you look at this, guys, if you look at this, what's my base for this particular thing? X. What's the exponent? 5. So that literally means take what times itself?
X times 5.
X
X times X.
X times itself 5 times. Right? Not X times 5, but X times itself 5 times. Good. Okay. Now, here's one. Remember, we talked about this. What's the base for this exponent?
XY.
The bracket. The parentheses, right. The bracket is the thing it's touching. So that means we need to take, and I really disagree. I think they should have written it with the brackets, but that's okay. So it's xy times xy times xy. Right? So it's not just the x times itself over and over, it's the xy. Now, when I multiply x times x times x, what do I get?
Sorry.
X.
Well, go ahead and do the multiplication. What do you get? X to the
Third
power. And what's a y times a y times a y?
Y to the third power.
Y to the third power.
Oh!
Y times y times y is how many of them?
3.
3 of them. Right? Yes.
So do we also have to put it into the single square?
Always. That's what algebra is all about.
But it takes too
Okay.
long. As you should make it up.
Well, some of us want to eventually get out of high school, right? Or out of middle school and go on to life. So you're going to get used to things that take too long. 1 minute, kids. Ready?
Wait.
Oh, no. What?
Go.
If you don't have to turn away your lights, so actually
But that's not an alphabetical order.
Well, your answer better be.
What?
Yes, it is.
X, Y, Z is alphabetical order, but Z, X, Y.
Don't focus. Don't get too caught up on that.
X isn't. Why is a sloth eating an X?
Shh. Just looking at it.
He's eating it.
Oh
It's a case high.
Yes.
Darn.
No, I'm almost done.
20 seconds. Should I just call on somebody?
Yes, call me. No.
I'm not calling on you two. Y'all have already answered questions. You've answered a question too. I want somebody new.
We're smart. Not really, but like, I like to have fun.
We're all smart.
Thank you.
Your dad is
Yes,
the
ma'am.
one that I-
Is it X, Y, Z, and then in brackets, and then a 3?
Okay, I like your thinking, and yes, you could think of it that way, but is that the simplest way to do it?
Can I say it?
That's true, right?
3 X, Y, Z.
No.
No, but what's the only numbers?
If they're all to the third power, then what?
And x to the third power times y to the third power times 2 to the third power.
Z to the third power.
Oh.
Yeah.
Okay, so why couldn't I say that? Oh, that.
Every one of them. So, here, look at how I'm going to do it, and then we got to go. It's x times what? Another x times what? Which is x to the third power. It's y times another y is y to the what?
Third power.
Z times another z is z to the third power. Yes, of course. All right? Okay, I didn't do the roll, so hold on, please. Is anybody missing? So y'all can just call me out a name.
As